Hi, welcome to the Shiko Math Practice Lab Algebra 2 lecture series. Today, we're going to start our lesson 1.3, and we're going to talk about the real number system hierarchy. And this is a very interesting topic. In fact, like if you later, in the college, you can take a class called the numbers theory. So basically, they will tell you all the good characteristics for different number and how it was, for example, the square roots was defined, how they find, how the people start to find those numbers here. Well, okay, but in here, since we are just starting the Algebra 2, so basically, in this video, we're just going to give a basic introductions, like what are each category for the numbers here. All right, so let me show you what type of the worksheet we're going to work today. So here we go, and so here, okay. So here is the worksheets we're going to work today. So I'm going to work on the 6 problems I highlighted in the blue. And then after that, you can go ahead and to practice, for the exercise I have there, you have 20 problems there. So you'll be able to try to work on these 20 problems by yourself to see you'll be able to identify that or not. Okay, so now let me go to the whiteboard, and now let's take a look at this real number system hierarchy and what is the meaning for each one here. Okay, let me go to the whiteboard. Okay, so here's the whiteboard here, right? So the real number systems here, right? So the real number, okay, so basically, okay, so let's see here. The real number, that means this is the numbers, so we call these real numbers. We typically use the capital R, try to represent the real numbers here. The real number really have 2 big categories here. So the first category we call is the what? We call it the rational. We call it rational. Then another branches here, we call it is the irrational. Okay, so what is the rational and the irrationals here? All right, so let's take a look at the rational numbers here, right? So under the rational number, the level 1, okay, so under here, we divide it into several levels. Okay, so the level 1s here, okay? So level 1, this is we call it the natural numbers here. So we use, we use the capital letter N to represent, and then, so this is we call it the natural number. Okay, so this is what we call it the natural number. So what is the natural numbers here? The natural numbers really is just like what is the number is like 1, 2, 3, 4, 5, 6. Those are the numbers we call these natural numbers here. So if you take a look in the real number lines here, okay. So if this is the real number lines here, and then, so this is the, so I think some of you are very familiar with those real number lines here. Okay, so this is like a 1, 2, 3, 4, -1, -2, -3, -4. So the real number is 1, 2, 3, 4, 5, 6. So it's all the positive integers, right? So those are those are the natural numbers here. That's what I'm color coding here. Okay. So now after the real numbers, then the next numbers we call it is the whole numbers, right? So whole number, I use the W to so this is what we call it. This is the whole numbers. So the whole numbers was discovered after the people recognize there is a number called zeros here. So that means the whole numbers include the zero. So it's 0, 1, 2, 3, 4, 5, 6, and da da da. So that's what we call is a whole number. So whole numbers here is included in here and included here and included here. Okay, so the whole number is just like the one extra zeros to the natural numbers. You might think, oh yeah, so but in the number theory's history, you find out it took a few hundred years for people to recognize what is the meaning of the zeros here. Okay, now after that, okay, so after this ones here, now we go into, okay, so we have the next ones here. We call it the integers. Okay, so the integers here. So the integer, let me use here, I call the integers. So I'm going to use the z to represent the integers. So this what we call is the integers here. Okay, so the integers here, so basically, people start to recognize, oh, I do have negative numbers here, right? So this is like a -4, -3, -2, -1, 0, and the 1, 2, 3, 4, right? So this is the next level is called the integers here. So that's why the z, that means now I'm not only here, I'm also is a positive here, 0, 1, 2, 3, 4. Also, I'm start to cover the negative numbers here, right? So that's what we call it is the integer. Okay, so the rationals here, right? So the next bigger category is the rational numbers. Rational numbers basically, yes, we use the q's, right? So let me see here. I use the q. What is, okay, I can use the q. Okay, so I used this color. Okay, this is what I call it rational. Okay, so what is the rational numbers here? That means that everything you can, the represent, that means you can represent by a fraction. That's what we call the ratio, right? So by a fraction. So that means if anything you can, by a fractions here is m over n. Of course, here n cannot be equal to 0, or the fraction is not defined, right? So the rational number, that means now, after like another maybe few hundred years, people start to know, oh, between those whole numbers, there's some number in between here, right? So everything, if you can represent by fractions, then it will be, we call this a rational number. So for example, 2/3, right? So 2/3 is is a rational number. Or like a 5/7, this is a rational numbers here. So that's why anything is decimal is rational numbers, right? So if it's 3.12, this is a rational number. Why? Because 1, 2 here, because 0.12, you can always represent by the 12 over hundreds, right? So anything like in the decimal, but of course, those decimals here, like you have to have a certain pattern. So like if you have the 0.66, like a point, let's see here. Like if you have this ones here, you say the 0.3333 and the da da da, or you can say the repeat the 0.3. Then this is a rational also. And you say why this is irrational? Because, you know, like later, I think in the later chapters in Algebra 2, we'll be able to physically show you, you can rewrite this into a fractions here, okay? So now that's why. So after people find the rationals, right? So that means we'll be able to fill a lot of those, you know, a lot of those space with rational numbers here. That's what we call it irrationals here, right? So anything you can write into a fraction, or you can write to a decimal. And even for the, you know, the infinity decimal is okay as long as it's repeat the patterns, right? So here this will be the repeat. Okay, so that's what we call it the repeat patterns here. But after even we find the rational, we still see some holes inside this real number line. That is where we call it is the irrationals here. So for the irrationals here, I'm going to use the I, try to represent irrational. Irrational, just like by its names, is those weird numbers, right? So the first number coming to your mind, what is this number? It's a pi's, right? So if you say, what is the pi's values here? So you will say the pi is equal to what? 3 pointer. So you will say, okay, pi is equal to the 3.1415.926 da 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 da. So even this is a decimal, but there's no pattern to this decimal. So it's 3.14159, right? So and other ones here, like you know, the later you will learn from the, you know, in the later chapter, that's the one of the other numbers we used a lot is we call this the e's, right? So for the e's here, so let's this is what we call is the e numbers here. So this number will give you the 2.7182a and the 1a da 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 da. So you know this is an irrational number because there's no fixed pattern. And now how about the square root of 2's here? The square root of the 2, so if you set the square root of the 2, so you will get the square root of 2 is equal to what? Is equal to the 1.4142135 da 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 here. So the same way is here if you set the square root of the 5 here, right? So the square root of the 5 here, you will get is 2.236067977 here. And so those are the, we call it irrational number. So it's no pattern. Even you have a decimal, but this decimal is not the repeat, right? So if your decimal is a repeat, then we know it is a rationals here, right? So the rationals here, right? So rational, you know, if you want to kind of do a circle, so the rational is here, right? So this is rationals, right? So rational, we use Q, right? So rational is Q. Inside the rationals here, right? So what is the next level? This is what is Z, right? So it's the integer. Then inside the integers, what is the next level? It's the whole numbers, right? So that is the W. Then the inside the W is what? Is n's, right? It's a natural number. So the way, so in here you will see if a number is a natural number, then it automatically become a whole number, automatically become the integer, automatically become the rational number. Of course, the largest ones here is what? The largest, the outside here is what is the real numbers here, right? Okay, so it's a real number, it's R's here, right? So that's we call it the hierarchy. Okay, now let's take a look at some of our examples here. So those examples are pretty straightforward. Okay, so, so the first one's here. Let me see here, right? So the first problem here is -3/2, right? So negative 3/2, as we talk about. So this is what? This is a fractions, right? Anything you can represent as a fractions. So what is these numbers here? So what is this number? This is rational, so it's a Q, right? As long as it's a Q, then it is R. All right. Okay, so now let's take a look at the next problems here. The next problem is the square roots of the 36. So we all know the square roots of the 36 is equal to what? Equal to 6, right? So the 6, that means this is a natural number. Like we said, a natural number is the lowest level. If it's a natural number, then will be whole number. If it's a whole number, will be an integer. If it is an integer, has to be a rational. If it's rational, has to be a real numbers, right? Okay, so now the next ones here is 66.6, and here the 6, this is repeat, right? So that means this number really is 66.6666 and continue. Because this is a decimal and this is a repeat decimal, so what do we call these ones here? This is obviously it's rational, so it's a Q. Because it is rational, it is real numbers. Right, so the next ones here, this is the square roots of the 2's, right? Okay, so for the square roots of the 2, like we talked before, because the square roots of the 2, if there's no fixed patterns here, right? So like we did a while ago, we said square roots of the 2 is equal to 1. So this is like equal to 1.4142 and 1, 3, and da 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 da. So there is no fixed pattern and no endings, right? So remember, this is no pattern and no endings, right? So what type of the number system we talk about here? So this is irrational. So we use I to represent the irrationals here. Okay, so now the next one's here. So this is negative 13.2. We say any decimal point, right? Any decimal fixed number of decimal, right? So I say this is the fixed numbers of the decimal. Is rational because I know the 0.2, I can change it to a 2/10, right? So the negative 13.2, obviously this is a what? This is rational, so it's a Q. If it's a Q, it's R. Get that? Okay, so the same way is here. This is 47.23. So this is the fixed. This is the 2 decimals, right? So if it's a fixed, it's a what? It's a rational. So if it's rational, it's R, right? Okay, so that's it. So this is what is the hierarchy of the real number systems. Like I said, this is a very interesting topic. In the college, they have the whole semester class was talk about the number theory. So they talk about all the good characteristics for each number system, for each category of the numbers, and how the people, for example, how do people find the square roots of the 2, and how do they define the square roots of the 2, and how do they find the lessons irrationals here. So it's a very interesting topic. Well, as we are the starter, and we just need to know the names and the definition about the different categories. Okay, that's it. That's it for this video, and it's very nice to talk to you about the number system. And you have a good day. And if you like the video, feel free to subscribe it, or you can send an email to me if you have any questions or any requests. Okay, so nice to talk to you, and you have a good day, and I'm looking forward to talk to you in our next lesson. Okay, talk to you later. Okay, have a good day.